Okay, so today we're getting to see that there are more than just 2 different or 3 different types of sequences. A lot of times students come into this course trying to remember from previous courses formulas and which ones that they do remember, what their names were, and kind of jumble it up or jump right into the formulas without understanding that a sequence has a rule or a pattern to possibly get from one term to the next. So, with that being said, there are more than just like the 2 or 3 sequences that you learned from previous courses. There are many different types of sequences. So we want to be able to develop a formula for each one. The formulas that we come up with do not apply to maybe that third one that you remember, where it's a recursive sequence. We're going to talk about what that looks like tomorrow or in a future lesson. When we want to write a formula for a sequence, we want to be able to kind of write it in the terminology for sequences, that is a sub n equals. You don't need it as a function unless you're collecting data and then you want to write it as a function. So this purpose is for the notation. We use a sub n in our course. That's the purpose of our notation, and identify that you have a sequence. And so n is the nth term, that's the number of the term in your sequence. The most apparent term is when n is 1, being that it's the first term of your sequence. All right, so we basically got that down. Now, as you saw in your journal, different kind of things going on. And so we're going to talk about if you see that you're adding a particular number to get from one term to the next. So whatever that number is that you're adding, okay, and if you add a negative number, that's subtracting, you multiply that with n and you add some sort of constant. And that may be just like 0. If you notice that you're adding, I'm trying to erase, an odd number consistently to get from one term to the next, okay? Or even numbers, then n is squared, and then you're adding some sort of constant. Sometimes it's very simple that students say, oh, that's a perfect square. But other times it may be off by some sort of constant, like you're subtracting 1 or adding 1,000 and you don't see it. So this is still that same kind of formula where n is squared. Next, so if you see that you're alternating between values, or more particularly, you're going from positive values to negative values, or negative values to positive values, then in your formula for a sub n, you have -1 to some power of n. That could be n, it could be n plus 1, or n plus 2, or n minus 1, or n minus 2, whatever is giving you that sign change. Okay? And there could be a combination of things here, but the most apparent one is maybe we're adding some sort of constant. Okay, not really sure. Maybe we're multiplying by that constant. We will see. So that brings me to the last but not least. If you see that you are multiplying by some number, it's the same as dividing. So that number is the base to some power of n. It may just be n. It could be n plus 1 or n minus 1, as I was describing in the last problem. Okay? It could be n plus 1. And that could be your rule or formula that will give you all the terms of your sequence. So it's important to identify what that number is that you're multiplying to get from one term to the next, and then just adjust it along the way. Sometimes you have to multiply it by some sort of constant. That's what I was talking about previously. So you got to see what you're working with and what will actually give you the terms of your sequence. So sometimes they're very straightforward, but other times it's like a combination of these things. So keep in mind that these are guidelines to give us our formula. And these guidelines need to be known so we can actually write the formulas for any sequence, not just the ones we learned in previous courses. All right, so here we're going to go to some examples. Okay, I thought I just had examples. The next slide is giving us a few notes, and I may have already said this. 1, n is the number of the term. 2, you may have to combine some of these guidelines. 3, check your formula for the first few terms of the sequence. So I definitely said these first 2 notes. So if you wrote down as I was saying them, awesome, you're a good note taker. If you didn't write it now, you can always pause the video, make sure you get it. The last one I didn't say yet because, well, we didn't actually do the examples. Make sure the formula works for the first few terms. You don't have to show a check. You can just do it in your head. But a lot of students will just make sure it works for like the first term or the first and second, and it may work out for those, but doesn't work for like the third or the fifth. So check for more than like the first 2. Okay, so let's look at example 1. Write an expression for the most apparent term of the sequence. I kind of already spoke about that before. It's also called an explicit rule when we write a sub n equals. So let's write this as 1a. And so you may see in this particular problem that we're adding 3 to get from one term to the next. So this is going to be 3 times n plus some sort of constant, okay? So later on we're going to find out how to find that constant using algebraic rules, but we can just make sure we add or subtract something that's going to get us to the next term. I said or subtract because if I plug 1 into my function right now, I'm getting 3. So I may have to subtract 2 in order for it to be 1. And then if I plugged in 2, 6 minus 2 is 4. And if I plugged in 3, 9 minus 2 is 7. Okay, and you can check even at the end. So if I plug in 6, 18 minus 2 is 16. So this is working out for me. And that's how we use the rules or guidelines there. In the next one, you're adding 3, but then you're adding 5, and so on. Okay, you're going to notice that you're adding consecutive odd integers. Okay, so this is where we would write a sub n equals n squared plus some sort of constant. But if I plug in 1 now, I'm getting the first term 1. I plug in 2, I'm getting 4, and so on. So you're pretty much checking your answers for the do now here. And notice that this is the problem, this is my work, this is my answer. So do the same thing when you have to do this for a test or for your homework. The last one isn't an a sub n thing. This is a sequence that's defined recursively. We need 1 and 1, the first 2 terms, to get the answer of 2. And then we need 1 and 2 to get the answer of 3. 2 plus 3 is 5, and 3 plus 5 is 8. And when we need terms before or terms after, like 5 and 8 to get 13, this is a sequence that's defined recursively. And I will not ask you to define a sequence recursively. Okay, the reason why is because I'm only going to ask you to write the explicit rule. This is the a sub n equals types. And the other reason is because we need to know not only this rule, and we use K's in recursive sequences in upper level math courses, K, not any N's, The reason why is because this is incomplete. And a lot of students do this and not realizing that the full answer would be that we need some sort of value to establish as, let's say, our first term or 2. Okay? So whenever I used to give this as like a bonus question in class, most students would never remember this part, or they remember part of it and not all of it. So I'm not trying to trick you, I'm just trying to educate you. So when you're writing recursive sequences, you do need to have a lot more information than just a one rule thing. So that's why I stick to you guys getting used to writing explicit rules, and these are the ones that we need to learn for future lessons anyhow. So let's go to example 2. Okay, so in example 2, okay, we're given the problem. The work would be plugging in the 4 values, 1 through 4, to get the first 4 terms. So wherever you see an n, we plug in 2 to get our second term, and 3 to get our third term, unless it tells you otherwise. You use 1 through 4 for the first 4 terms. Okay, and then you can list your answers. You can write the subscript for each one, such as a sub 1 equals 6, a sub 2 equals 9, a sub 3 equals 12, a sub 4 equals 15. Okay, whatever you want to do to write your answer. All right, so I'm going to do the next one also, 2b. Let me know if you have any questions, because I feel like I'm going a little fast here, but I think you guys get the idea and can catch up if necessary. Now, I like giving this particular example because you get to see that -1 is just some power of n, just n by itself, and that you're adding a constant to it, like I was describing with those guidelines that I gave you. So we end up with answers for the first 4 terms as 2, 4, 2, 4. So even though we weren't alternating with signs, okay, we were alternating between the values of 2 and then 4, and then 2 and then 4. So you can see how or why that occurs, why we need the -1 there. So keep that in mind for future problems. All right, let me know if you have any questions. Good luck.